In the modern world, astronomy stands as one of humanity's most powerful tools for understanding the universe. We chart the motion of distant galaxies, study the atmospheres of alien worlds, and trace the origins of time itself, fall from observatories here on Earth and telescopes drifting through space. From guiding spacecraft to decoding the cosmic microwave background, astronomy shapes the future of science, technology, and exploration. But astronomy wasn't always held in such high regard. Long before it became a science, it was simply curiosity. The dawn of astronomy. Prehistoric times. Thousands of years ago, early humans looked up at the sky and began to notice patterns, the rising and setting of the sun, the shifting constellations, the changing shape of the moon. They didn't have telescopes. They didn't even have writing. But they watched. And they remembered. These observations weren't just for wonder. They were essential for survival. The sky became a calendar, a compass, a clock. Ancient people built great stone monuments, like Stonehenge in England or Nabta Playa in Egypt, aligned perfectly with the solstices and stars. These weren't just structures, they were tools for tracking time and understanding the world. Even in prehistoric caves, we find markings that may represent star maps, constellations, or lunar cycles etched long before recorded history began. This was the true beginning of astronomy, not equations or theories, but the deep, instinctive desire to find order in the chaos above. Early civilizations: Babylon, Egypt, and China. As human societies grew, so did their understanding of the sky. The first great leap came with the ancient civilizations of Mesopotamia, home to the Babylonians, who began recording celestial events with remarkable precision. They tracked the movement of the sun, moon, and planets. They noticed eclipses, charted Venus's strange path, and divided the sky into constellations, many of which we still use today. For them, astronomy was deeply tied to astrology, used to predict omens, guide kings, and time religious rituals. In nearby Egypt, the stars became tools of power. The rising of Sirius marked the annual flooding of the Nile, vital for agriculture. The Egyptians aligned temples and pyramids with celestial bodies, embedding the heavens into their very architecture. Meanwhile, in China, early astronomers catalogued comets and eclipses, keeping detailed sky records for over 2,000 years. Across the world, the sky was no longer just a mystery, it was a system. Predictable, trackable, divine. Greek astronomy, the birth of scientific thought. In ancient Greece, astronomy began its transformation from mysticism to mathematics. Thinkers like Pythagoras proposed that the Earth was a sphere, not because they had proof, but because they believed the universe must be perfect. There is geometry in the humming of the strings. There is music in the spacing of the spheres. Then came Aristotle, who supported this idea with simple observations like the Earth's curved shadow during a lunar eclipse. All men by nature desire to know. Later, Aristarchus of Samos dared to suggest that the Earth orbits the Sun, a radical idea for the time. The fixed stars and the Sun remain unmoved, while the Earth revolves about the Sun in a circle. But the most influential figure was Claudius Ptolemy. His Earth-centered model, with planets moving in complex circles, dominated for over 1,000 years. I know that I am mortal, but when I trace at my pleasure the windings to and fro of the heavenly bodies, I stand in the presence of Zeus himself. Greek astronomy marked a turning point. The stars were no longer just signs, they were subjects of study. Predictable, measurable, governed by laws. Islamic Golden Age. Astronomy preserved and perfected. As Europe slipped into the Dark Ages, knowledge from the ancient world was at risk of being lost. But in the Islamic world, a golden age of science was just beginning. From the 8th to the 14th century, scholars across the Middle East and North Africa preserved Greek texts and built upon them with rigorous observation and innovation. In Baghdad, al-Battani refined solar calculations and improved models of planetary motion. It is incumbent upon the astronomer to establish the motion of the stars by observation. In Cairo, Al-Hazan ibn al-Haytham laid the foundations of the scientific method and optics. The duty of the man who investigates the writings of scientists is to suspect them all. Persian mathematician Omar Khayyam created a solar calendar more accurate than Europe's Julian version. And in the observatories of Maraga and Samarkand, astronomers like Nazir al-Din al-Tusi and Ulugh developed models that would later inspire European thinkers. They didn't just preserve ancient astronomy, they evolved it. The Copernican revolution, a sun-centered cosmos. In the 16th century, one man challenged the ancient view of the universe. His name was Nicolaus Copernicus, and he proposed that the sun, not Earth, sat at the center of the cosmos. In his book, De Revolutionibus, Orbium Coelestium, he wrote, "To comprehend the wonderful workings of God's laws must be a pleasing and acceptable mode of worship." Copernicus's model was elegant, but controversial. It quietly defied centuries of belief and church doctrine. But the spark had been lit. Soon, other minds would ignite a cosmic fire. The birth of modern astronomy. Danish astronomer Tycho Brahe spent decades recording planetary positions. His data became the foundation for a breakthrough. His assistant, Johannes Kepler, realized that planets move in elliptical orbits, not perfect circles, and derived three mathematical laws of planetary motion. The diversity of nature's phenomena nourishes the human mind. While Kepler redefined the math, Galileo Galilei changed how we saw the universe. Through his telescope, he discovered craters on the moon, moons around Jupiter, and stars beyond imagination. The book of nature is written in the language of mathematics. Though condemned for defending heliocentrism, his discoveries helped solidify it as truth. Then came Isaac Newton, who united the heavens and earth with a single force, gravity. If I have seen further, it is by standing on the shoulders of giants. The universe was no longer divine. Chaos, it was a machine, ruled by physical laws. For centuries, Newton's laws shaped astronomy. But the 20th century brought a deeper understanding. In 1915, Albert Einstein proposed general relativity, redefining gravity as the curvature of space-time. Imagination is more important than knowledge. His theory explained black holes, time dilation, and the bending of starlight, ideas that sounded like science fiction, but proved to be real. Then, Edwin Hubble made a staggering discovery. Galaxies are moving away from us. The universe is expanding. This led to the Big Bang theory that the universe had a beginning and has been growing ever since. Today, we study dark matter, dark energy, and the search for life beyond Earth. We send telescopes to orbit and rovers to other planets. And yet, the deeper we go, the more mysteries we find. From the earliest humans who first looked up and saw patterns in the stars, to the ancient civilizations that built monuments and calendars, to the bold thinkers who dared to challenge old beliefs, and the modern scientists who continue to push the boundaries of what we know. Astronomy is more than just a science. It is a story of human curiosity, resilience, and imagination. It reminds us that no matter how small we may feel in the vastness of space, our desire to understand the cosmos connects us all. And as we continue to explore, to question, and to dream, astronomy remains our key not only to the future of science and technology, but to the story of who we are. The stars above are still waiting. All we have to do is keep looking.